Hi, in this video we're going to look at a super complicated example of a derivative that involves product rule, quotient rule, chain rule a couple times. So kind of all mushed in one problem together. So if you can get through problems like this, you can probably deal with any of the derivatives that you need to up to this point anyway. All right, so when you're looking at a problem like this, one of the first things I would pay attention to is where are the variables in the problem. That helps you kind of see what the structure is, what you're going to need to use in terms of rules. I would notice I have a fraction here with variables on the numerator and denominator. So the overall structure of the problem is going to be quotient rule. So in a little bit, I'm going to set up some parentheses with some labels for quotient rule. Within quotient rule, though, I might notice that I have a couple of other rules going on. On the denominator, I have a product of two functions here involving x times the exponential function e to the negative x. So there's going to be some product rule there. So we'll have some product rule when we take the derivative of the denominator. The other thing I might notice here is that I've got a couple places where I have functions inside other functions. And so there are at least a couple of instances of chain rule going on in this problem as well. All right, so we'll identify where that chain rule is in just a second here. I'm going to start, though, by noticing that the overall structure of the problem, when I look at the problem overall, that's going to be quotient rule. So in order to kind of set up a framework for myself so that I don't get lost in terms of what I'm doing, I'm going to set up some parentheses here for quotient rule. I'm going to leave some space, so I have a little bit of scratch workspace there. So dy dx, and I'm just going to set up some parentheses here with some labels and thinking about that a little bit. Okay, so when I think about the overall structure of quotient rule, I've got this set up. I'm going to just then have to fill in some derivatives where I need to fill in derivatives. And so really the only two places where I'm going to need to be using additional rules at the same time is those places where I take the derivative of the top and the derivative of the bottom. So those other parentheses I have set up, I'm just going to be putting in the bottom function or the top function, and those are just going to go right in there. I'm not going to need to use product rule or chain rule there. All right, so I want to look a little bit more at the original function. I'm going to erase some of this scribbling I did on the original function so we can kind of write on it a little bit more. Okay, so when I look at this original function and I think about taking the derivative of the top and the derivative of bottom, and what we're going to need to do as we do that to fill in our quotient rule down here. On the top, I notice that I have this squaring of a tangent function, so I want to maybe rewrite that so that I'm clear about what is the inside and what is the outside function. So I've got the squaring is the outer function, and then inside that I have a tangent function. And then there's actually even another layer of chain rule there, because I don't just have tangent of x, I've got tangent of something else. So I've got really two layers of chain rule here when I go to take the derivative of the top. The outermost function is the square function. And then the next layer of function inside that is the tangent function. And then the very innermost function would be the 5x. I'll write innermost. So we'll have a couple layers of chain rule going on there when I take the derivative of the top. So I may want to set up some parentheses for that, again with labels, just to help me remember what I'm doing, how chain rule works. So there's my setup of chain rule. I'm just going to need to fill that in. And then here at the end, where I've got the other highlighted place where I'm going to need to find a derivative of something, I'm going to need to find the derivative of the bottom. And probably I didn't leave enough space there. So I'm going to pause this for a second, rearrange some parentheses to make this last parentheses where it says der bottom bigger, so I have enough space there. Okay, so all I did was just extend that last parentheses a little bit so that I've got some space for finding the derivative of the bottom. The other thing that I want to do here is label the original fraction. I had an equal sign here that wasn't quite correct yet because the numerator was equal to tangent of 5x, the whole quantity squared, but I also should have the denominator here. So I'm going to write that here and then mark that up a little bit. So I'm going to need product rule in the denominator when I find the derivative of the denominator, because I've got a product of two functions involving x. So there's my product. And then I'm actually also going to need chain rule when I find the derivative of the denominator, because here I don't just have e to the x, I have e to something else, e to some other function of x. So there's a little layer of chain rule there within the product rule. So when I go to take the derivative of the bottom, this last parentheses I have highlighted here, we're going to be using product rule and a little chain rule there as well. Okay, so let's get started setting up some product rule parentheses there with some labels, and then I'll go in and fill in everything. And that derivative of the second, that derivative of e to the negative x, is where I will need chain rule. So I'm going to have a couple parentheses in there, derivative of an outer function on that chain rule times the derivative of what's inside that. Okay, so notice I haven't actually put anything in here. I've just set up an entire structure, but now it is just a matter of kind of following my directions and do what it says. So this first big parentheses, maybe I'll block it off here with brackets, where we had the derivative of the top. Right, derivative of the top, and we're going to use chain rule when we do that. I'm going to fill that in first. All right, so the outermost function on the top is the squaring function. The derivative of something squared, I just bring down the exponent and subtract 1, leave the inside alone. Right, so I took the derivative of the squaring part there, bring down the 2, subtract 1. Then I need to take that times the derivative of what's inside that. So the next inner function is tangent of 5x. Derivative of tangent is secant squared. And leave the inside of that alone. That was taking the derivative of the tangent layer. And then times the derivative of that innermost function. So derivative of 5x is 5. So that was 2 layers of chain rule there. All right, so derivative of the top, we're done with that. Next, times the bottom, just the bottom. I just need to write that here. Minus the top, that's my tangent squared of 5x. Times, all right, and then I'm going to be taking the derivative of the bottom. And so on the bottom, I've grouped that into a first function and a second function. And when I take the derivative of that second function, I'll need chain rule. So the derivative of the first, derivative of x is 1. Times the second function times e to the negative x plus the first function x times the derivative of the second, and here's where I'll use chain rule. So derivative of e to a power is e to that power, leave the inside function alone, then times the derivative of what's inside there. The inside function in the exponential function is negative x, so derivative of negative x is negative 1. All right, so there's a lot of stuff going on there in the numerator, but so far we're just taking derivatives and following our instructions, and we're almost done. Actually, I just need to write the bottom function, and it's already squared. I put the square in to start with. All right, so there's my derivative. It's a big, old, ugly mess, but at that point I have the correct derivative. So if I don't need to simplify it, I could just leave it exactly like that. If you type this into online homework, you got a lot of parentheses and timeses and brackets to type in. If you're turning it into me and you leave off parentheses, it's not quite correct. So if you're leaving it like this, you want to make sure you have everything perfect. You wouldn't have to simplify it. I'm going to go ahead and do that though, just to make sure we're clear on how that works. So I'm going to scroll up to give myself a little space here. All right, so the next thing I want to do is just tidy this up a little bit so that we've got a kind of clean form of our answer. So there's a couple things I would do. The first thing I might do is just write this without the extra parentheses that I used to set up my structure. So on the numerator of the fraction before the minus sign, all that stuff is just times each other. All that stuff is times each other. There's no addition and subtractions there before we get to the minus sign that's in the middle of quotient rule. So all that stuff's times each other. When I simplify this, all I'm really going to do is just tidy that all up so it's all one giant term. The coefficient out front is going to be from the 2 times 5 or 10. And then this stuff's all just times each other. So whatever order I want to write it in, that's okay. I probably would do the x e to the negative x next, and then the 2 trig functions, just because sometimes when you stick stuff behind a trig function without parentheses, it's confusing about whether the trig function applies to that extra stuff after it or not. So, all right, one big giant term all before the minus sign. All right, then minus. Okay, and then if we look at what we have after the minus sign on the numerator, if I look at all this here, I've got the tangent squared 5x, and then in that next group I have a sum of two terms, the 1 times e to the negative x, and then plus, and then another term here. So when I simplify this last part, I'm really going to be using a distributive property here. I can distribute that tangent squared of 5x to this first big term, 1 times e to the negative x, and then the tangent squared of 5x times the last term here. I want to be careful about that as well. Maybe I'll make this plus a negative to make sure that I don't mess up, that I have to distribute through that minus sign as well as part of the tangent squared of 5x. Okay, so when I do that, I'll have negative tangent squared 5x times 1 times e to the negative x. So that will be minus e to the negative x tangent squared 5x. You can write that in either order, but I like to put the trig functions at the end. And then the next term here, I'll have negative tangent squared 5x times e to the negative x times negative 1. And since I'm distributing through a negative, and I'll be taking that times a term that involves a negative, I'll have a negative times a negative, which will just be a plus. And then, let's see, the coefficient will just be 1, x e to the negative x tangent squared 5x. Okay, so that's the whole numerator. That was the hard part. The denominator here, I just have one term squared. So I could leave it like that, or I could simplify that a little bit. There's a couple exponent properties that I'm actually going to be using here. I'll write them over here to the side. So one of them is if I have a times b to the n power, that I can think about that as a to the n times b to the n. Notice I don't have more than one term here in the square function. Just two things times each other to the second power. So I'll use that and square the x and square the e to the negative x. And then the other thing I might think about in terms of properties of exponents is to think about what happens if you have a power and then you raise that to another power. So a to the m to the nth power, and you multiply those exponents, a to the m times n. So I'm going to just block those off here to the side, but those are the two exponent properties that we're going to use to simplify the denominator. Okay, so on the denominator I'll have x squared, and then when I multiply the exponent on the negative x times 2 e to the negative 2x is what I'll have there on the denominator. Okay, so I could leave my answer like that if I want. The other thing to do might be to look for some cancellation when you have a fraction, maybe some cancellation that you could do. I might notice that there is an e to the x, e to the negative x factor in each of the three terms on the numerator, and I have an e to the negative x factor on the denominator, so I could do some factoring out and canceling. There are other common factors on the numerator. There's a tangent of 5x in all the terms on the numerator, but because there's no tangent function on the denominator, I can't really do any canceling with that. So I probably would go ahead and factor out the e to the negative x from all the terms on the numerator and cancel that with what we have on the denominator, or cancel that with one of the e to the negative x's on the denominator. When you're doing all of this simplifying on an exam, one of the things you need to think about is whether you're required to, whether your teacher is asking you to, or you need to because you're going to use the derivative for something else. If you're not required to, this takes a lot of time and it's pretty easy to make a mistake. So sometimes it's easier to just leave your derivative in an unsimplified form. All right, so my goal here in factoring out that e to the negative x was to make it cancel with one of the e to the negative x factors on the denominator. Remember, on the denominator, what we had in the previous step, this was really e to the negative x, the quantity squared, that e to the negative 2x. So when I think about canceling, the e to the negative x factor that I factored out would cancel with one of those factors of e to the negative x on the denominator, but I would be left with another one. So, all right, so let's just write a final finished answer here. 10x tangent 5x secant squared 5x minus tangent squared 5x, my tan is ugly there, plus x tangent squared 5x, and then pay careful attention to what you have left on the denominator. I was a little sloppy with that. I'm left with an x squared times an e to the negative x. All right, so I would probably leave my answer like that. There may be times where you don't want to leave negative exponents in your answer, and so you could do some simplifying with that. Or maybe convert your secants and tangents to sines and cosines if that seems helpful. But it kind of depends what you're going to do with this derivative as to why and how you might do any other steps. So for right now, we're just finding derivatives, so I'd probably stop there.